Hi.
Hi. Right, okay, so that should be live on YouTube now. All right, so let's have a look at some chemistry, and we're going to look at relative masses, moles to start with, building up to balancing equations, and then going all the way to looking at some of the yield work. So your grade 1 to 3, describing what an atomic mass is, 4 to 6, calculating them, and then all the way from 7 to 9 will be some of the higher tier stuff where you calculate the number of moles given the mass of a substance. So to start with, what is a relative atomic mass? So a relative atomic mass is the mass of a single atom. So the mass of a single atom is so tiny. Sorry, let me start again. So relative atomic mass is how we compare things to different atoms, because the mass of a single atom is so tiny that the actual number would be so small that it's just not practical to use when we in experiments or calculations. So instead, we use the relative masses of atoms, of different atoms, to carbon-12. So as it is a relative scale, so you have like a reference point, so you're saying how much bigger than this point is it? It's used as carbon-12, it's 12 units because it's 6 protons, 6 electrons. So all other elements are compared with a standard carbon element. But don't worry about it too much. Now, on your periodic table, you have, so last time I put up a periodic table, I got kicked out of TikTok for copyright for some reason. So I'm not going to put it up on the screen, but if we have a periodic table, so you got magnesium, you'll have a mass number which you will be find in the corner. So that's your A, we're going to call it the AR number. So we're going to say that's our relative atomic mass. So you could pick out some questions, any elements from your periodic table, and you can have a look, and we can look at atomic numbers, and we'll have a look at mass numbers. So on a periodic table, you're given 2 things, and you're also given a key. So let's take sodium. So this would be a good time, if you've got a periodic table in front of you, to have a look at it. You can see that the atomic number that's given is 11. The mass number is 23. Now this atomic number tells me my number of protons. So my number of protons must be also 11. So my number of protons is 11. And my mass number is my number of protons plus my number of neutrons. So in this case, my neutrons is 12. And my protons and electrons are the same. So the number of protons will be the same as my number of electrons, which will also be 11, for example. So if we take another one, if we take bromine, from the periodic table, you'd read the number 35 off. You can read the mass number of 80 off. So that 35 tells me it's the number of protons, which, because it's just bromine, is also the number of electrons, and 80 minus 35, which is 45, gives me the number of neutrons. So that should be revision, and that should be something that makes sense and you've seen before, and that's using numbers from your periodic table. So let's think about a formula for a substance. So let's take, for example, calcium carbonate, so CaCO3. So what is this telling me? This tells me I have 1 calcium, and because it's 1, it's a calcium atom. I have 1 carbon atom. And I have 3 oxygen atoms. Right, So in this case, you'll be able to split something out and the number next to it tells you the amount. So you've got 3 oxygen in this case. So if we had sulfuric acid, which is H2SO4, here you've got 2 hydrogen atoms, 1 sulfur atom, and because the 4 is next to the O, you've got 4 oxygen atoms. Right. So we're going to look at the relative formula mass. The relative formula mass of a compound is the sum of all the relative atomic masses. So remember the relative atomic mass of the periodic table, that one number. When we look at the relative formula mass, which we call MR, is when we look at it all combined. So let's take calcium carbonate as we've got it here. So if I just get rid of that, we look at calcium carbonate. We've got 1 calcium atom, which if we look up on our periodic table, we find out for that we've got, it's going to be 40. 1 carbon atom, which is 12. 3 oxygen atoms, and if you look up the number for oxygen, you get 16, and you're going to have 16, and that's times by 3, which gives you 48. So your MR, or your relative formula mass, is going to be adding those all together. So you're going to have 40 plus 12 plus 48. So altogether, your relative formula mass for calcium carbonate is 100. So you could work those out for anything, and that's your first step. So your first step is what's an MR? It's taking each of the different components, you figure out how many atoms of each you have, you take your numbers from your periodic table, and you add them all up. So now we're going to look at the concept of moles. So this takes us on to a concept of moles. So a mole of any substance always contains the same number of atoms. Now, because it's a huge value, because the atoms are so small, the huge number, we have a value for it, and it's called the Avogadro constant. Right, and this value, which you're given in the exam, 6.02 times 10 to the 3 atoms in every mole. So 1 mole is made up of this many atoms. Right. So we can then do some calculations where we have our number of moles. We can use using working out them if we have a mass and we have the MR or the AR if it's just one thing. So your formula is number of moles is equal to mass in grams divided by, now this is either your AR if it's one thing, or it's your mass in grams divided by your MR. And for those of you that like triangles, you'll have your mass in grams, you'll have your N or your number of moles, and you'll have your MR here. Okay, so you can think of it as a triangle if it makes it easier. And the triangle helps you to rearrange things. So let's take some equations, take some questions rather, and let's just solve them. So let's just do a few questions and see how we go. So if we had to find out, let's take an exam question. Right, so we've got how many moles? So you want to know how many moles of sulfuric acid, so H2SO4, are there? How many moles of sulfuric acid molecules, I'm not writing out the whole thing, are there in 4.9 grams? Okay, so the first step is to find the MR of sulfuric acid. So you're going to look up hydrogen, sulfur, oxygen. You have 2 hydrogens, 1 sulfur, 4 oxygens. When you calculate that, you get 98. So then your number of moles is equal to your mass divided by your MR. So in your calculator, you've got 4.9 divided by 98, which gives you 0.05 moles. Now, if we were to rearrange the equation and we wanted to find out a mass, it would be moles times MR. Now, with your exam questions, they tend to do things to the power. So you might get, you know, what is the mass? What is the mass? The mass of, let's say, 5.2 times 10 to the 7 moles of copper. So make sure you know where to find the 10 to the power of button. So on my calculator, it's above a button that looks like this. There's like, got log, and then you've got 10 to this. And that's the button that you need to be able to type that in. Or you could just use the X to that and type 10 and then put it in, but you can do it in one step using that 10 button. So the MR, or actually it's the AR because it's just a single thing, of copper, look it up in your periodic table, gives you 64. So therefore we know that our number of moles times our MR is going to be 5.2 times 10 to the 7 times 64. And you will get a massive number, because if you think about it, 5.2 times 10 to the 7 has got 6 zeros on it. And then we're timesing it by 64. So we end up with, so when I plug that into my calculator, let me just tell you how it gives it to you. Okay, so it might give it to you all in, without it in standard form, it might give it to you like this, 0, 0, 0, 0, 0, 0. Remember, this is in grams, but we know that 1,000 grams is 1 kilogram, still a big number. We could write it like this, so in kilograms. So it's a very, very big number, but make sure you know how to write those in your calculators. Okay, so that takes us through, and I've gone through that quite quickly because we looked at this before, and this should be, a lot of this should be revision almost. And what we're going to look at now is actually using all this information to be able to balance equations and reacting masses before we look at limiting masses. So let's first think about balancing equations. If we look at magnesium plus oxygen. Now, when I add magnesium to oxygen, I get magnesium oxide. So if I think about that, that's 1. So I've got magnesium. Now, oxygen is always 2 oxygen atoms together, and magnesium oxide looks like this. Okay. So we're going to look at the number of things on both sides of the equation, the number of atoms on both sides of the equation. So on this side, I've got 1 magnesium atom. I've got 2 oxygen atoms. And I've got 1 magnesium. And I've got 1 oxygen. So it doesn't balance, right? So if I was to represent them by circles, I've got 1 purple circle here. Got 2 pink ones, 1 and 1 purple. Okay, and what I want to be able to do is, how can I make this so this balances up? So what I could do is, if I add a magnesium to this side, that means on this side I need to add a magnesium and also an oxygen because they come as a pair, but now everything is totally balanced because I've got a 2, 2, and then 2, 2 on this side. So the way I represent that in the equation is I put a 2 in front of here and a 2 in front of here. So if we think about it, so a balanced chemical reaction, so a chemical equation needs to be balanced because there's something called conservation of masses. So that means your mass on both sides have to be the same. So a balanced chemical equation, when the number of different atoms on the left equal those on the right. So on the reactants, so those are the things going into the equation, is equal to those on the product side. So let's take something, you know, to decide how we would balance it. So if you had to decide if something was balanced, so we're going to take a few equations and we're going to decide if they're balanced. So if I take calcium carbonate, calcium oxide plus CO2, while I write these down, you can sort of start thinking about it and decide. H2O plus O2, Na plus Cl2 gives me NaCl. Okay, so the first one, I think, okay, calcium. I've got calcium on this side, I've got one on this side, okay? Check, balanced. Right, carbon, I've got one carbon on this side. So I've got one carbon on this side and I've got one carbon on this side. Perfect, nicely balanced. Here I've got 3 oxygens. I've got 1 plus 2, which makes 3. Perfect, so that's balanced. I don't need to worry about it. Let's look at the next one. On the left-hand side, hydrogen, well, I've got 2 H's here and I've got 2 oxygens here. On this side, I've got 2 H's, that's good, but I've got 3 oxygens, so it's not balanced. So I have to say, okay, what can I do to sort that out? So the thing that I've got on this side is I need to get more oxygens. So if I increase this one by 1, this becomes 2. So now I've got 4 hydrogens and 4 oxygens. And here, if I wanted to make this into another one, if I put a 2 here, that gives me my 4 hydrogens, got my 2 plus my 2, so my 4 oxygens. It's like a bit of a puzzle. And now it's balanced, now I'm happy. Next one, on the left-hand side, I've got 1 sodium, 2 chlorine, 1 sodium, 1 chlorine. Not balanced. I want to balance something, so I'm saying, okay, let me balance the chlorine. So I'm going to put a 2 on this side. So that's going to make this 2 and this 2. So I need to get an additional sodium on this side. So I put the 2 there, there's 2 there now, and it all balances. So I've balanced my equations. I'm thinking what's on the left-hand side and what's on the right-hand side. Right, so what does a balanced equation tell you? It tells you the moles. So this is telling me, so I've still got, if I think of this here, I have 2 sodium molecules, 1 chlorine molecules, and 2 sodium chloride molecules. But it's also telling me I have 2 moles of sodium, 1 mole of chlorine, and 2 makes 2 moles of sodium chloride. So the number in front is giving you the number of moles. And the way that helps you is you can use that to work out how much of the masses have reacted. So this is taking it up to another level. So this is making it a little bit harder. So the total mass of the products is equal to the mass of reactants. So that's called conservation of masses. So the masses will always be the same. I'll explain what I mean by that. So if we take, let's take, gives you 2 HCl, right? And we're going to look up the MRs. So if we take the MR of hydrogen, on my periodic table, hydrogen is 1, but I've got 2 here. So MR is going to be 2 here. Chlorine is 35.5, but I've got 2 of them. So that's going to become double that, so 71. HCl is going to be 35.5 plus the H, which gives me 36.5. So this is just the MR of the compounds. So the 2 only matters if it's at the bottom here. How many moles do I have? So the moles of hydrogen I have, H2 here are 1, because there's nothing in front. Chlorine is just 1, because it's as if it's a 1 in the front. And here I've got 2. Now, if you remember, your mass is your MR times your moles. So we're going to multiply this, and we're going to get our mass. So 2 times 1 gives us 2 grams. 71 times 1 gives us 71 grams. 36.5 times 2 gives us 73 grams. And you can see that when we add them up, it's the same. So that's your masses have been conserved. And that's another way to check your work. If you had time, you could work out the masses and you could check it that they were the same on both sides. So the way this is tested though, it will give you some of the numbers and you'll have blanks which you need to fill out. And if you always lay it out in this sort of grid fashion, then there's no reasons why you wouldn't get your answers for this. Okay, so, and I'm talking a lot, but let's try work through some examples. So if the questions, let's find an exam question. Okay, you have a solution containing 100 grams of sodium hydroxide. What mass of chlorine do you need to convert it to bleach? And they give you this equation. So they tell you sodium hydroxide. So they've got sodium hydroxide plus chlorine gives you bleach, which plus sodium chloride. You're not expected to know this equation. It's an equation that you would be given, plus H2O. Okay, so plus some water. And another part of the equation required you to balance it, which just required a 2 there. So now the question says, I've got 100 grams of sodium hydroxide. How much bleach sodium hydroxide, how much chlorine do I need? We've written the question out wrong. So how much chlorine do I need to convert to bleach? So I'm thinking, okay, what are the bits of this equation that I'm worried about? It's only really the sodium hydroxide and the chlorine that I'm concerned with. So I've got my 2 NaOH and my Cl2. So those are the 2 bits that I'm trying to use. Step 1, my MR. So MR of sodium hydroxide. So sodium plus oxygen. So we've got 1 plus 16 plus 23. So sodium is 23, oxygen is 16, hydrogen is 1. Add them up, we get 40. Chlorine, 35.5 times 2 gives me 71. What are the masses? Well, I know I have 100 grams of this. This is my question mark. I don't know this one. Right. So what about my moles? So how would I work out my moles? So I've got 2 moles of sodium hydroxide, right? And for each mole of sodium, I need a mole here. So we could do it that way around. So it says, how much chlorine do I need? So you could set out your calculation. in such a way that you're saying, okay, well, that's 100. So what do I need to do now? So let's think of our triangle. We've got our mass, we've got moles, and we've got MR. So we know the mass, we've got the MR, so we've got our moles here, 2 moles here, and we only need 1 here. So our missing number here is the mass, which we can see, how would we get that to make sense? Now, if we did it that way around, the problem is our masses aren't conserved. So it's not one to check. So this isn't the most, so the way to do this is actually say, how many moles of sodium do we have? We don't actually have 2. How many moles of sodium do we have? Sodium hydroxide. The moles that we have is our mass divided by our MR. So we've got 100 divided by 40. So we've got 2.5 moles. Sorry, I was about to do this question differently. Just realized what they're asking. But 2.5 moles of sodium hydroxide. So that means how many moles of chlorine do I need? I know for every 2, I need 1. So if I've got 2.5 moles of sodium hydroxide, that means I need half the number of moles of chlorine. So I need 1.25 moles of chlorine. And then I can fill in my missing number, which is my mass. So if I want to find the mass, I cover up mass, it's moles times MR. So 1.25 times 71. It's not going to come out as nicely. This is why I should probably do these questions before I set them to you. So you get 88.75 grams. And that's probably why it was 5 marks. So 88.75 grams is the mass that you need. Okay, I'm going to do another question because I started this the wrong way around with you. So let's take exactly the same. So we're going exactly the same. We're going to have the same format. And what we're going to do is we're going to say, instead of 100 grams, I'm given 250 grams of sodium hydroxide. So let's take that 100 grams away, make that 250 grams. And I'm going to say, what information do I know? Well, I know I need 2 lots of sodium hydroxide for every 1 chlorine. I know the MR is 40 and 71. I know the mass of sodium hydroxide is 250 grams, which means I can calculate the moles by doing mass divided by MR, which gives me 6.25 moles. Now, for every 2 moles of sodium hydroxide, I get 1 more mole of chlorine. So I get half the amount. So I divide that by 2. And that gives me, I'm doing this all on a calculator. So you would do it all on a calculator, 3.125. In order to find the mass, I do moles times MR because I cover up the top of that triangle. So I times that by 71. And I get 221.875, something around that. So 222 grams. So now let's try going from masses to balanced equations. So if you're given masses of things, how you can balance the equation using masses. And it's the last bit that we'll do. Okay, so if I've got, all right, let's find another exam question. Okay, so we've got sodium nitrate. So sodium nitrate decomposes, oh God, that doesn't make sense. Decomposes to give a nitrite and oxygen. Okay, so we've got sodium nitrate, and that decomposes to give you sodium nitrite and oxygen. Okay, you don't need to know the formula, like I said. Check it's balanced. Na, Na, N, N, 3. So it's not balanced, and we're going to try use some equations to help us balance it. So we're told in the question that we have 17 grams of sodium nitrate. We have 13.8 grams here, and it produced 3.2 grams of oxygen. Okay, so if we had to use this to balance the equation, step one, find the MR, always your step one. MR of sodium nitrate, so Na plus N plus 3 lots of oxygen gives you 85. NaNO2 gives you 69, and this gives you 32. So those are from your periodic table. Now, step 2, convert it to moles. Now, let's put our triangle up on the side. Mass, moles, MR. I'll just do it. So my moles is my mass divided by my MR. So 17 divided by 85, which gives me 0.2. Then I've got 13.8 divided by 69 gives me, I'm just going to round it to one decimal place, 1.2. It gives me 0.1888884 something. And then 3.2 divided by 32, which is 0.1. So 3.2 grams divided by 32 to give you 0.1. And then your last step is you divide by the smallest number. So our smallest number, we identify our smallest number, which is 0.1, and we divide everything by 0.1. So 0.2 divided by 0.1 gives you 2. 0.2 divided by 0.1 gives you 2. 0.1 divided by 0.1 gives you 1. So this tells you to balance it, you need a 2 and a 2 here. Now, I know you could have looked at it and you could have figured out and balanced it, but they want you to use, they will have asked you to use converting the equations to do so. So, or they might say, is this the correct amount? Is it balanced? And you would do it like that. So maybe if we take, see if I can, yeah, so I'm going to leave it there for the moment. I hope that was useful. I know that's quite a lot there. So what we will look at, so the idea is to do this again tomorrow, to look at maths at 5 to 5:40ish, then look at some science, and I will rotate between chemistry and physics. I'm not a biologist, can't help you there. I probably could, but I wouldn't be 100% confident with it. So I hope that was useful, and I shall hopefully see some of you tomorrow. And